Hello students, I hope all are doing good. Today we will start with our next topic, that is exponential and logarithmic functions. So to solve these problems, let us briefly go into our exponential, what it means and how we have to solve, and logarithmic functions. Suppose I consider a graph, consider y is equal to x square. It is a parabola, something like this it comes. You can see here your x square, if it is 2 raised to 2 will be 4, so your y value will be 4. Suppose if I have x cube, so my again graph will be like this. If I have x raised to 4, I'll get like this. As you can see this, the power increasing, the same your graph is getting close to your y, it is getting steep. Now if I put here 2 raised to 4, it will be 16 again. 2 raised to 5 it will become again 32. It will be coming like this. It is getting steeper and steeper. So here exponential, what we call b raised to x they have done, y is equal to b raised to x, where your b should be greater than 1, where your b is greater than 1. Suppose if your b is less than 1, think your b is less than 1, like if it is in a negative or anything, if it is in a negative, minus 1 raised to x, if it is 1 means it comes in minus 1, right? It comes to this quadrant, and that is it cannot come to this quadrant. Yes, it cannot come to this quadrant. So your b should be always greater than 1. That is our essential criteria. Even you call f of x is equal to e to the power x as our exponential. Generally if you see, we call e to the power x as exponential. Now here what is the difference? Here you see b is a constant and x is an independent variable. Yes, this is independent and this is dependent variable, right? This constant is raised to independent variable and the constant should be greater than 1. Here it is e raised to x. Here this e value, it lies between 3 and 2, somewhat 2.33 something it is. I guess you have studied in your physics while doing your some experiments and all, it will be there. So e value lies between this. Here you can consider 2 and 3, somewhere in that between your e value it is. Now you have one power series like this. You have 1 plus 1 by 1 factorial plus 1 by 2 factorial is equal to so on. This is called sum of e. This is sum of e. So whenever you have this factorial, e to the power x means this sum, its sum is 1 plus 1 by 1 factorial plus 1 by 2 factorial. Now if I have, suppose y is equal to 10 raised to x, yes, 10 raised to x, or y is equal to a raised to x. See, this everything is called as exponential itself. See, it is not like this only y is equal to e to the power x is only exponential. No, this is also exponential, this is also exponential, and this is also exponential. Okay, but this is just a constant, and here you should tell your 10 is greater than 1, your a is greater than 1. This is your criteria. Yes. Now suppose your x is negative. Now x you get as minus 1. So y is equal to 10 raised to minus 1. If you take, means I can write it as 1 by 10, right? 1 by 10 it will be. 1 by 10 I can write 10 raised to minus 1. I can write it as 1 by 10. If I take 1 by 10, its value is what? 0.1. 0.1 means it will come somewhere here. See, it will be coming like this. Now if I make your graph, see, you can see. Now suppose you have a graph, okay, it is passing like this. So the line will be coming here. If I get a negative, if I get 10 raised to minus 1000, so it will be 1 by 10 raised to 1000. So 10 raised to 1000, anything you get only, right? So it will be coming in a point wise. In a point wise you'll get, and the point wise gets here. So it will be getting here steeper. It will be getting, but it won't touch your x line. Okay, but it won't touch your x line. So if you take as a 10 raised to x, you can see it is passing through 0, 1, where your x axis is 0 and y is 1. You can tell 0, 1. Here also, any graph in your this 0, 1 lie on all exponential. Even in this also, a 0, 1 lie on all exponential function. Okay, that is one condition you can tell for that. 0, 1 lie on all the exponential function. Now differentiation of this, how we will do? Yes, you have a to the power x, okay, differentiating this with respect to x. How you have to differentiate? Its formula is what? A to the power x log a to the base e, log a to the base e. So this log a to the base e, this log e, this base is known, it is called as natural logarithm. If you have e, you call it as natural logarithm. The base, if it is e, it is called as natural logarithm. If it is except then e, if you have 10 or a you have or 20 you have, that is called as a common logarithm. Now in this place only d by dx 10 raised to x, it is in the form 10 raised to x. So what is the formula? So it is a raised to x means this is 10 raised to x log a is what here 10, log a 10 to the base e. Yes, you have to differentiate in such a way. Now differentiation of e to the power x, how we do? E to the power x log e to the base e. Log e to the base e is what? 1 itself. So you get ex. So differentiation of ex is ex itself. When you get differentiation of ax, it will be a to the power x log a to the base e. Okay, this I guess I have given you in the formula. Now how you have to differentiate this exponential form? Now suppose differentiating e to the power 2x. Yes, e to the power 2x. Now what is the differentiation formula for this? Differentiation of e to the power x is e to the power x. So differentiation of e to the power 2x is, first what we write? E to the power 2x. Okay. Then here you see here upper part you have 2x, you have 2 and x. So again this you have to differentiate, again interior differentiation you have to do. This if you can consider 2 into x. How we do in our chain rule? We have done, right? This whole, if it has x, differentiation of x is what? 1. This will be into 2. So this will be 2 e to the power 2x. 2x differentiation, how we do? Do 2 into dx by dx. So differentiation of dx by dx is 1. So 2 into 1 will be 2. So e to the power 2x into 2 it becomes. Now if you have e to the power minus 2x, first we do the whole, that will be e to the power minus 2x itself. E to the power minus 2x, again interior differentiation of this will be minus 2. So this is minus 2 of x. X differentiation is what? 1. So it will be minus 2. Yes, in this way you have to differentiate the exponential formulas. Now if you have d to the power dx, a to the power 2x if you have in such a way, here you see a to the power x differentiation formula is what? A to the power x log a to the base e. So we will do like that only, a to the power x log a to the base e. But again here you can see it is 2x. So again differentiation of 2x will be 2. So in such a way you have to do the exponential differentiation. So that's all base, like you should know the exponential. In your exponential function, you know the values goes on increasing. When whatever values you put, the graphs goes on increasing. So exponential function, write down this. The exponential function is the positive base, b greater than 1 is the function, that is y is equal to f of x. Your b, the base b should be always greater than 1. Next is the point 0, 1 is always on the graph of the exponential function, which I said you 0, 1 will be always in the graph of the exponential. Means it is a restatement the fact that b raised to 0 is equal to 1 for any real b greater than 1. Any b greater than, if you take 2 raised to 0, if b is greater than 1, they are telling, in place of b, if I put 2 raised to 0 means it will be again 1. Okay, 2 raised to 0 also it will be 1, 3 raised to 0 also it will be 1, 5 raised to 0 also it will be 1, 100 raised to 0 also it will be 1. Okay, anything. Just the condition is b should be greater than 1. Then exponential function with base 10 is called common exponential function. Sum of the series, as I said you, f of x is as 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 up to so on. So whenever they tell sum of e to the power x means you should know that this is this. Y is equal to e to the power x is called our natural exponential function and the values lie between 2 and 3. See, this is like in considering in the point of examination, so this is all they won't ask, but it is very good for your kind of CT and all. Okay. Now next is our logarithmic function. What is our logarithmic function? Now we have b to the power x is equal to a, as your b should be greater than 1 from your exponential, right? B to the power x, something we are getting a, where your b should be greater than 1. Now logarithmic, how we do? Log a to the base b is equal to x. See, of this only, if you want to find the x value, how it becomes? If you want to add up this both you have to combine, so it becomes log a to the base is equal to x, means the value whatever you get, apply log, and here, so you can see this value whatever you will get. See, for any base what number you should get, okay, what number you should get, this log gives us. For example, now suppose, see 2 cube is what? 2 cube value is 8. So in terms of log, how we write? Log 8 to the base b is equal to 3. So log 8 is equal to 3 means its base will be 2. So like this it plays. Your logarithm means in such a way. In general we write log b such that r terms to r, means this is what? Positive numbers. Yes, it should be positive number. R plus positive number means what here? And this r is a range, like here you are getting a range powers, right? You are getting the range values, that you call it as a range, and we tell your b should be greater than, means your base should be greater than, and it should be positive, that itself, positive real numbers. Here you see, now you have your x, b raised to x, okay, or here you see 2 raised to 3. So can this be negative? Yes, this can be negative, positive, or even 0 also. As I have said you, see anything, if I get, I had taken 10 raised to x itself only, okay. In place of this, if I have 10 raised to minus 10, how I can write this? 1 by 10 raised to 10. So answer, I'll get something, right? Even in a decimal means I'll get something, okay. I will get 1 by 10 raised to 10 will be 10,000, so again it will be 0.0. So that in total I'll get in a positive number only. Answer will be a positive only. We should get our positive numbers. If I take 10 raised to 0, I have said you 10 raised to 0 will be what? 1. This is our positive real number only. If I take 10 raised to 1, that also will be 10. So if I take positive, if I take 0, if I take negative, x can be any value. This x, it can be positive, it can be negative, it can be 0. But the b, the term b, whatever it will be, it should be only positive. The base should be always positive, okay. This is the things you should know. Logarithmic function, you can write let b greater than 1 be a real number. Then we say that logarithm of a to base b is x, that is b to the power x is equal to a. It is defined as, in general I said you, log from r plus to r. R plus means what? Positive numbers, and this is your range. B is base. So I have given as x tends to log x to the base b is equal to y if b to the power x is equal to a. B to the power x is equal to a. In your log, the point 1, 0 always lies on the graph of the function. Log x to the base e, you know, to the base e, log x to the base is equal to y. This is called always natural log. Even you can write it as ln x. When they give ln x, you should understand that the base is e. If you don't have base e, see here log x to the base 10, base they will mention, so that is called as common logarithm. It is called as common log or common logarithm. In your any books, especially now in an NCERT, if the log is to the base e, they may just give as log x. If only you have a log x, you should understand that the base is natural, means this is a natural logarithm, means base e. For a separate, if they give you some separate base like 10, 2, 3, they will mention it. That is called common log. And say log 1 is always 0. Log 1 is equal to 0. Let the base be anything, whatever the base be. Let the base be anything. Let it be natural log or let it be common log, log 1 will be always equal to 0. So, this is some points. Then we will next go to our properties, and then we will jump up to our exercise part. Okay. These all are the basic things which are required for your small examination part of you. So, please just make the notes. Thank you.